Happy Thursday, mathematicians. Let's go ahead and complete a skill lesson building off of what we learned yesterday with dividing fractions by whole numbers. We talked about how to check our answers and evaluate the expressions using a tape diagram. And then we also learned the standard algorithm for fraction division for the first time. So we're going to take some time to review both of those skills, and then I'll send you off to do some practice. So let's first take a look at the diagrams. I wanted to make sure that you knew how to draw and solve them. So if you remember, if you can see, I wrote out all the steps and I'm going to draw and talk you through them as well. We will first use the dividend to create your tape diagram. Remember, the dividend is, go ahead and let's put it in blue. The dividend is the first number. Remember, it's your total in the fraction expression. And the way you do that is your denominator tells you the number of pieces that you break the tape diagram into. For example, with 3/5, I have 1, 2, 3, 4, 5 pieces. And then my numerator tells me how many are shaded. For example, 3/5 divided by 2, that would be 3. So I would shade here. Sorry, this is not my best shade. Right, so now I have my dividend. Let's see step 2. Use your whole number to determine how many groups to split your tape diagram into. So I have my tape diagram using my dividend. I'm going to use the whole number or my divisor, which I will underline in this like pink-ish color. That's my divisor that tells me how many to split it into, which helps me determine what line I should draw, right? So if I need to split it into 2 new sections or groups, I'm going to draw one line. Then my next step to evaluate the division expression, that means to come up with my quotient or my answer. The next step I take, see step number 3, my numerator is the amount of shaded squares in one of your new groups. So it is not a common misconception is that I have to add up each of these squares. I don't need to do that because what I did was break the original tape diagram into more pieces in doing my division. But I don't actually have more squares shaded. I still have that same amount. So what I'm going to show you is that I only need to count my first group. So let's say I circle my first group in orange right here. Here, I guess I'm going to outline it as a square. Here is group 1, and then here is group 2 right down there. I'm only looking at one group. I'm going to go ahead and draw an arrow right here just so you know what I'm talking about. And then I'm going to circle, let's see, I have 1, 2, 3. So, oh my gosh, Miss Matters has a typo right here. I will fix that. My numerator is going to be 3. And hey, that's a good moment to realize that I make mistakes too. I'm human like you all. And it's okay. When I make mistakes, it actually helps me remember concepts better. And hopefully I don't make that mistake the next time. But if I do, again, it's just another learning opportunity. So that's how I view my mistakes, is just learning opportunities. But anyway, I found my numerator by looking at the total number of shaded squares in one group. So it doesn't matter how many groups I create. I just need to look at one. My denominator is the total number of new pieces or parts. So let's go ahead and mark my denominator with purple. I'm going to draw dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is my denominator. So my answer to this problem is 3/10, and that is how I create and then use my tape diagram to solve. Now let's take a look at the standard algorithm. The new vocab word that we learned today is the reciprocal. Remember, I want to go over the reciprocal before I go over how to do the algorithm. The reciprocal or inverse is when you flip the numerator and the denominator. So your numerator of your fraction then becomes your new denominator, and your denominator then becomes your new numerator. So if I had the fraction 3, which is equal to, I'll just do a little drawing over here. So like 3, not in that color though, it's difficult to see. So remember, a whole number can also be turned into a fraction by putting the whole number over 1. So to get it to 1/3, I just need to flip them. So my numerator becomes my denominator, and my denominator becomes my numerator, which equals 1/3. And remember, please pause this video at any time when you need to write stuff down. All right, I'm going to go ahead and erase that. Until I find my reciprocal. So in order to put that all together with the algorithm, to divide using my standard algorithm, what I do is I multiply the dividend by the reciprocal of the divisor. And the way I'm going to remember to do that is I'm going to tell myself KCF. K stands for keep the dividend the same. C stands for change the division sign to multiplication, and then F stands for flip the divisor or find the reciprocal. So if I'm drawing here, my K step is going to be, let's just put it in green. Let's do a little color coding here. So I keep the dividend the same. All right, so 4/6 stays. All right, my next step, let's do it in orange, is change the division sign to multiplication. Okay, and remember when I'm multiplying by a fraction by a fraction, I just multiply the numerator by the numerator and the denominator by the denominator. Okay, my final step, which let's just mark it in blue so we remember, as I need to flip the divisor, find the reciprocal. So I know that 4/1, if I'm finding the reciprocal, 4/1, the reciprocal of that, I'm going to flip them, is going to be 1/4. So then I come down here for my multiplication, do 1/4. Let's double check. So I kept my dividend the same. I flipped I changed my division sign to multiplication, and then I flipped the divisor. So let me finish solving. 4 times 1 is equal to 4. 6 times 4 is equal to 24. And now I could reduce that if I wanted to, but we're not going to get into it right now, so I'm going to leave it there. And that is my answer. I put both of these slides as notes in your work as well. If you'd like to refer back to them, you can always pause this video whenever, take notes, screenshot, that sort of thing. Good luck. Remember KCF, and then remember the steps we went over to determine how to evaluate an expression using a tape diagram, how to create it, and then what means what within the tape diagram. Happy Thursday!